In this video, we're gonna talk about the derivative and the different rules in differentiating algebraic forms. First rule is the derivative of constant. Let's see is a constant, and the derivative of a constant is 0. The derivative of c is equals to 0. For example, your y is equals to negative 5 minus pi. So dy over dx is equals to the derivative of your y, which is negative 5 minus pi. Since y is equals to negative 5 minus pi is a constant, hence the derivative is equals to 0. Another example, y is equals to 16. Find the derivative of y is equals to 16. Derivative of y is equals to the derivative of 16 is equal to 0. Second rule, the derivative of a power. The derivative of the n power of a variable is a product of n and n minus first power of a variable. Or to differentiate x to positive integer power, take the power and multiply it by x to the next lower integer. Derivative of y is equals to derivative of x raised to n is equal to nx raised to n minus 1. Where n is greater than 0. Let's try this one. Find the derivative of y is equal to x raised to 6. So the derivative of y is equals to x raised to 6. Is equals to 6 times x raised to 6 minus 1 is equals to 6x raised to the 5th power. Another example. Find the derivative of y is equals to x raised to 8. Y is equals to x raised to 8. So the derivative of x raised to 8 is equals to 8 times x raised to 8 minus 1, which is equal to 8x raised to 7. Third rule, the derivative of a constant times a function. Let's see, be it a constant. If f of x is a differentiable function at x, then so c of f of x and the derivative of y is equals to the derivative of c times f of x is equals to c times the derivative of f of x. Let's try an illustrative example. Y is equals to 6x raised or 6x cubed. So derivative of y is equals to the derivative of 6x cubed is equals to 6 times the derivative of x cubed which is 6 times 3 times x raised to 3 minus 1, which is equal to 18x squared. Another example, find the derivative of 2/3 x cubed. The derivative of 2/3 x cubed is equal to 2/3 times the derivative of x cubed is equal to 2/3 times 3 times x raised to 3 minus 1 is equal to 2x squared. Fourth rule, the derivative of sums and differences. Let y is equals to u plus and minus v, where u is equals to f of x and v is equal to g of x. Are differentiable of x, then derivative of y is equals to the derivative of u plus and minus v, or equal to derivative of u plus and minus derivative of v, or d is equal to u plus and minus v, which is equal to du plus and minus dv. Let's try an illustrative example. Find the derivative of y is equals to 3x cubed plus 5x squared minus 3x plus 8. Solution. Derivative of 3x cubed plus 5x squared minus 3x plus 8 is equal to 9x squared plus 10x minus 3. Another example, find the derivative of y is equals to 8x raised to 4 minus 2x cubed plus 6x plus 7. So derivative of y is equals to derivative of 8x4 minus 2x cubed plus 6x plus 7 is equal to 32x cubed minus 6x squared plus 6. Next, the fifth rule, derivative of a product. The derivative of a product of two functions is the first function times the derivative of the second plus the second function times the derivative of the first. So let y is equals to u times v, where u is equals to f of x and v is equal to g of x, are differentiable functions of x. Then derivative of y is equals to derivative of u times v is equals to u times the derivative of v plus v times the derivative of u, or derivative or d is equal to u times v, which is equal to u dv plus and minus v du. Let's try an illustrative example. Find the derivative of y is equals to 4x cubed minus 2x squared times 3x raised to the fifth plus 4x squared. So let u is equal to 4x cubed minus 2x squared. Then du, or derivative of u, is equals to 12x squared minus 4x. And v is equal to 3x raised to the fifth plus 4x squared. And the derivative of v is equal to 15x raised to the fourth plus 8x. And now, let's try to get the derivative of this. Derivative of 4x cubed minus 2x squared times 3x raised to the fifth plus 4x squared is equal to the value of our u, which is 4x cubed minus 2x squared times the derivative of our v, which is 15x to the fourth plus 8x plus the value of our v, which is 3x raised to the fifth plus 4x squared times the value or the derivative of our u, which is 12x squared minus 4x, is equal to, get the product. So we have 60 x raised to 7 plus 32 x raised to the fourth minus 30 x raised to the 6 minus 16x cubed plus 36x raised to 7 minus 12x raised to 6 plus 48x raised to the 4 minus 16x cubed. And we have 96x raised to 7 minus 42x raised to 6 plus 80x raised to the fourth minus 32x cubed. This is now the derivative of our function. Another example. Find the derivative of 2x cubed minus 4x squared times x squared plus 2x plus 1. Let u is equal to 2x cubed minus 4x squared. So du, or the derivative of u, is equal to 6x squared minus 8x. And let v is equal to x squared plus 2x plus 1. Then the derivative of v is equal to 2x plus 2. Okay, let's try to use the formula or get the derivative using this. So dy over dx is equals to derivative of 2x cubed minus 4x squared times x squared plus 2x plus 1 is equal to the value of our u, which is 2x cubed minus 4x squared times the derivative of our v, which is 2x plus 2, plus the value of our v, which is x squared plus 2x plus 1, times the derivative of our u, which is 6x squared minus 8x. And we have 4x raised to the 4th minus 4x cubed minus 8x squared plus 6x raised to the 4th plus 4x 4x cubed minus 10x squared minus 8x. And then we have 10x raised to the 4th minus 18x squared minus 8x. And this is now the derivative of the given function. Next, the sixth rule, derivative of a quotient. Let y is equals to u over v, where u is equals to f of x, v is equals to g of x, are differentiable functions of x, and v is not equal to 0. And then we have derivative of y with respect to x is equals to derivative of u over v is equal to v times derivative of u minus u times derivative of v over the squared of the v, or v squared, or we have d times u over v is equals to v du minus u dv over v squared, or v times the derivative of u minus u times the derivative of v over v squared. Let's learn an illustrative example. Find the derivative of y is equals to x squared plus 1 over x cubed minus 1. Let u is equals to x squared plus 1. So du over dx, or the derivative of u, is equals to 2x. And v is equal to x cubed minus 1. And the derivative of v is equals to 3x squared. The derivative of x squared plus 1 over x cubed minus 1 is equal to our v, the value of our v is x cubed minus 1 times the derivative of our u, which is 2x, minus the value of our u, which is x squared plus 1, times the derivative of our v, which is 3x squared, all over the squared of our b is x cubed minus 1 squared. equals 2x raised to the fourth minus 2x minus 3x raised to the fourth minus 3x squared all over x cubed minus 1 raised to 3. Squared rather. And we have, so negative x raised to the fourth minus 3x squared minus 2x all over x cubed minus 1 quantity or close and open parenthesis squared, which is equal to negative x times x cubed plus 3x plus 2 all over the squared of x cubed minus 1. Next rule, the derivative of reciprocal. The derivative of reciprocal of a function is the negative of the derivative of a function divided by the function squared. So let y is equals to 1 over v, where v is equals to g of x, is differentiable function of x, and v is not equal to 0. Then we have derivative of y is equal to derivative of 1 over v, which is equal to negative derivative of v over v squared, or derivative or d derivative of 1 over v is equals to negative derivative of v over v squared. Let's try an illustrative example. Find the indicate derivative of y is equal to 1 over x. So y is equals to 1 over x. The derivative of 1 over x. So we have negative derivative of x over x squared equal or is equal to negative 1 over x squared. Next rule, the derivative of a function with rational exponent. Function with rational exponent. Derivative of y is equals to derivative of x raised to 1 over m, which is equals to 1 over m times x raised to 1 over m minus 1, where m is not equal to 0. Let's try an illustrative example. Find the derivative of y is equal to 2 over x raised to 1 half. Y is equals to 2 over x raised to 1 half. We have 2x raised to negative 1 half. So derivative of y is equals to derivative of 2x raised to negative 1 half is equal to negative 1 half times 2 times x raised to negative 1 half minus 1 is equals to negative x raised to negative 3 halves, which is equal to negative 1 over x raised to 3 halves, or we can say that we have negative 1 over x square root of x. Next, the chain rule. If y is a function of u and u is a function of x, then y is a function of x or composite function. Hence, the derivative of y with respect to x is the product of the derivative of y with respect to u and the derivative of u with respect to x. Derivative of y with respect to x is equals to derivative of f times g of x is equal to derivative of y with respect to u times derivative of u with respect to x, or derivative of y with respect to x is equal to derivative of y with respect to u times derivative of u with respect to x. Let's try an illustrative example. Y is equals to x squared minus 3x plus 5 raised to 4. So let u is equals to x squared minus 3x plus 5. So du, or derivative of u with respect to x, is equals to 2x minus 3. And our y is equals to u raised to 4. So dy, or derivative of y with respect to u, is equals to 4u cubed. So derivative of y with respect to x is equals to the derivative of our u, which is f of g of x with respect to x is equals to the derivative of y with respect to u times derivative of u with respect to x is equal to 4u cubed times 2x minus 3 is equals to 4 times the value of our u, which is x squared minus 3x plus 4 cubed times 2x minus 3. Okay, this is now the final result. The last rule, the general power rule. Derivative of y with respect to x is equals to derivative of u times x raised to n with respect to x is equals to n times u times x raised to n minus 1 du over dx, or derivative of u raised to n. Let's try an illustrative example. Use the general power rule to find the derivative of y is equal to the square root of x plus 1 over 2x minus 1. Solution. So derivative of y with respect to x is equals to derivative of x plus 1 over 2x minus 1 raised to 1 half minus 1 is equal to 1 half times x plus 1 over 2x minus 1 raised to negative 1 half, because 1 half minus 1 is equals to negative 1 half times times 2x minus 1 minus x plus 1 times 2 over x minus 2x minus 1 squared is equal to 1/2 times 1 over x plus 1 over 2x minus 1 raised to 1/2 times negative 3 over 2x minus 1 squared is equal to negative 3 all over 2 times 2x minus 1 squared square root of x plus 1 over 2x minus 1. So, the derivative of y with respect to x is equals to negative 3 all over 2 times 2x minus 1 raised to 3/2 square root of x plus 1 or negative 3 negative 3 all over 2 times 2x minus 1 raised to 2/3 times x plus 1 raised to 1/2. Okay, that's it. And that's are the different rules in differentiating algebraic forms.